My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, An Assessment of the Phytoremediation Potential of Planted and Spontaneously Colonized Woody Plant Species, on Chronosequence Fly Ash Disposal Sites, in Serbia. Global coal fly ash is a byproduct of coal power plants. Last few decades has seen extensive research into finding ways to use fly ash in various sectors, such as the construction material industry, road building, and also soil amelioration. The revegetation of ash deposit sites is one of the best solutions for the physical and chemical stabilization of this mobile substrate. Because of their root systems, plants absorb and bind trace elements, thus preventing erosion and their leaching, while improving habitat quality both microclimatically and aesthetically.
Fly ash is a complex, heterogeneous material, silty in texture with extremely variable physical and chemical characteristics conditioned by the geological origin of the coal, the combustion process, storage method, length of exposure to weathering, morphological characteristics, and the size of ash particles, which have a considerable impact on its chemical composition and the solubility of chemical elements.
That is so intriguing, Boson. It is mainly composed of essential chemical elements, but also contains non-essential and toxic elements which can have a negative effect on plant growth and metabolism. In this study, the potential of planted and spontaneously colonized woody species for the phytoremediation of potentially toxic trace elements from the Chronosequence fly ash deposit lagoons at the Nikola Tesla A thermal power plant in Serbia were analyzed.
Results show that there are differences in the concentration of trace elements in the roots and leaves of the examined plants at the lagoons. All examined plant species accumulated chromium the most in the root, which suggests that they are good stabilizers of this element.
That is a very interesting observation, Boson. Biological indices for arsenic identified T. tetrandra and A. fruticus species as good stabilizers of arsenic. P. alba species stood out as accumulating the highest levels of boron, nickel, and zinc. T. tetrandra species the highest levels of copper, manganese and selenium, and R. pseudoacacia species the highest levels of arsenic and boron in leaves, which makes them good extractors of these elements from the fly ash.
To conclude, these results prove the hypothesis that this spontaneously colonized woody species, thanks to its high effectiveness in the stabilization of fly ash, is suitable for use in the sustainable revitalization of fly ash at the fly ash disposal site, as well as similar ash deposit sites worldwide.
In addition, it has a whole range of advantages over the other examined species, such as its capacity for vegetative propagation, its extensive root system, its enriching fly ash with nitrogen, and its tolerance to the prevailing conditions at fly ash lagoons. A Fruticosa species has great potential for the sustainable phytomanagement of fly ash disposal sites. That was an interesting paper. Hope you liked it, Boson.